Okay, well, we'll go ahead and get started. I already see some people on the chat are putting in where they're coming from. So when you join, just put in where you're coming from. I have some questions and some prompts to get to know who is all here. So I'll be asking those and then kind of looking at trying to look at the YouTube chat while I'm going through this. But Alexia will also be giving me the questions back.
Yes.
Well, so thank you everyone for joining. I know it's, for some people it's very early in the morning and for some people it's late at night. So thank you for coming to my workshop today. We're going to be talking about monitoring your models in production. I'm Amber. I'm a machine learning engineer at Arise. I'm a former astronomer, and I also was head of AI for Insight Data Science and did a stunt as a product manager at Splunk, working on integrating AI into existing tools. I do want to post a few links. Should I do that on the Zoom
Please
chat?
send me them to the Zoom chat, and then I will put them in the description, because YouTube might not like links coming from you.
I see.
It might think that you're a spammer, because usually spammers put links. So I will put this in the description right now. And now your Twitter handle makes sense, Astronomer Amber. I was going to ask you about that, like why it's Astronomer Amber, but now it's clear.
Yes. So yeah, a lot of the stuff in GitHub too is Astronomer Amber, because I first kind of broke into the area of AI through astronomy, which probably a lot of folks in the audience, if this relates to you, were also in academia, did data science, did physics, did maths, did some kind of engineering, and then saw AI really picking up. And so that's where we're going to get into these models that you're building and how to monitor them in production today. So the links I put one to join our Slack community. We're a very active Slack community group. One for the ML observability course. We have a free course if you want to learn more about ML observability. It takes a few hours to complete, and it's more lectures of me talking. So if you think I explain things well, hopefully you enjoy that free course.
It's a nice one. I'm taking it too.
Yes, thank you. And it's the first course on ML observability, which when you hear ML observability, I'll get into kind of exactly what it is a bit. But yeah, there's 6 different units in that course, so you can really dive in deep. And also there's an unstructured unit. So that I know that appeals to a lot of folks here. There's also a challenge. So we're going to be walking through the whole workshop. If you do complete like the Google Forms challenge and submit it, you can win swag, and we'll send you some swag if you complete that form. Otherwise, there's the link to the free account. So you can create your free account, and then we can walk through this whole workshop together. So there's also, you can go to the Arise website, you can scan the code, you could go to the bit.ly link. There's several different links for you to be able to sign up for your free account. It takes about a minute or so to sign up. And again, please join the Slack community. We're always having great discussions, and not just on ML observability, but kind of all things with like the latest AI models. So we're going to first go into what is ML observability. I'm sure a lot of people have that question that they want answered first. Then we'll dive into a specific use case. We'll do some Q&A, and I like Q&A all throughout the workshop. I like it to be very interactive. I know we're all working from different locations. A lot of us work from home, so as engaged as possible. I love answering questions on the fly. And then we'll get into the hands-on workshop, and again, like more Q&A, because maybe we won't get to bias tracing, maybe we won't get to unstructured use cases, but I'd love to know if that's something that you're really interested in. So a few questions from you. I know some people already put it in, but I just want to know like where people are coming from, what you're working on now. And I will try to go into also the YouTube chat for me to see it. But Alexei, if anyone's asking
I can run a poll actually. Like for the second one, has anyone here put a model into production? I guess it's binary, like yes or no. So then I can run a poll. This is cool thinking. Hopefully, yes. Yeah,
it's
I can
very tech savvy.
start
Running the polls, like you got a handle on it. And so if anyone's put a model into production, and experience with that, or experiences with trying to maintain a model in production, what makes that challenging? Some folks here are very new to ML observability. Maybe you've just built models and you don't necessarily think about like what are best practices when I put this into production. But I know there are a decent amount of folks here who have put a model in production. And a key thing is like not to put it in production on a Friday night. If you know why that's a key thing, please respond in the chat. Love to get that discussion going. And then I'm just curious if anyone's heard of the term ML observability before.
I will ask that too in a poll, but probably we should wait a bit to see the results for the first question about putting models in production. So far I see that no is leading with 55, 54%.
Okay.
Just like 50-50, more or less.
50-50. Okay, great.
I see that at 24 votes right now, so I'll wait for like a bit, maybe 25, and then I'll close it, and then I'll start another one about this term ML observability. Are you going to explain it right now? Because maybe I should run the poll.
Yeah, I'm going to explain it. And yeah, just kind of like seeing people's feedback on these. So it's good to know, like right now, people are kind of at a 50-50 with putting models into production. That's pretty good. And a lot of times folks that come to my talks on ML observability, maybe they're not at that point, but they're looking to transition into industry. And a lot of questions they'll get in the interview process are about what would you do if you put a model into production? Because you'll do the system design, you'll build the model, and then you'll be asked like to think about what to do in production, because these models, they touch millions in revenue, they really impact customer success. So just making sure teams are kind of thinking about that, and you're thinking about that if you're preparing for an interview process. So let's just get started. A lot of folks are attending this because they either have put models into production, or they're interested in seeing best practices from research to production. At the beginning of this process, you could be working on your Jupyter notebook, everything can be looking great, and then you put that model into production, and then things start going wrong. All of a sudden, you're dealing with feature changes, you're dealing with drifts, and you have to figure out where that issue is actually occurring. This is the slide I think that gets a lot of attention when I do talks. A lot of folks are taking photos of this slide, mostly because of the stats. We find that 84% of teams say that it takes at least a week to detect and fix a model in production. And the next closest to that was saying it takes at least a month. A majority of the time, teams don't even know there is an issue in production until customers are calling and saying like, hey, there's something wrong, or there's something weird going on here. And that's really the last thing we want. We want to be able to have a quick time to resolution. We want to be able to find that error fast and know where it is in the data and how to correct it. So that's really where ML observability comes in, not just waiting for things to break, but being proactive. And the companies that are really leveraging this are anywhere from early stage startups with about 10 models in production to companies well over 100 years plus. And whether you have one model in production or 100 or 1,000 models in production, implementing best practices is going to help you maintain things like maintenance and customer service and have enhanced user experience. Really want to make sure that your models are operating optimally. And you're not just retraining based on an arbitrary time, like, oh, it's been 3 days, we should retrain, or it's been 6 months, we should retrain. You want to make sure you're retraining on a needs basis. Where we see the time divided on the ML pipeline in the last 5 years, the majority of that is on the data prep, followed by the model training, model deployment, and then finally the production side. Teams say that they spend on average less than 1% of time in production. And it's not because there's not issues going on. It's not because there shouldn't be time spent. It's really hard to find best practices or to know what to do in production. Where do you even start looking? These models are huge. Often they cascade into other models, and knowing where to start can be extremely difficult. And again, that time to resolution, being able to know when something's broken and how to fix it is key. And the key problems that we see that plague almost every team we talk to are the model and data drift, performance degradation, and data quality issues. And then more and more teams looking at fairness and bias, model readiness, model interpretability, coming up more and more. And a reason why it's not easy to monitor in production is for that first part of that MLOps pipeline, you have really standardized tools, advanced tools that integrate well, and they can take care of the data prep, the model training, and the model development, and really assist you on best practices. But it's that last mile that's extremely difficult. What do we do about the prediction? What do we do about the operational decisions? And then teams will try to either write, a few clauses, a few if statements, or try to string together a list of existing tools or try to repurpose them. And it really turns out the integrations for this are incredibly difficult. And if you're repurposing a tool, it's not going to always give you what you need. Sometimes we don't know what we don't know. So having a tool specifically designed for the task is going to be key. And that's where ML observability comes in. And just to give everyone a concrete understanding of what
Maybe
ML.
I'll interrupt you.
Yes.
Because you might be
poll.
interested in
Yeah.
like the poll results. So it's actually
Yes.
50-50.
50-50. Okay, great. Yeah, perfect timing. So it seems like it's 50-50 on those that have heard of ML observability. Sometimes when you think of observability, you think of network observability. So just giving a concrete definition, it's the software that helps teams automatically monitor AI, understand how to fix it when it's broken, and ultimately improve data and models. And I just wanted to say the difference between ML observability and ML monitoring. ML monitoring is 100% necessary. Everyone should have ML monitoring, but it's just the tip of the iceberg. You need that red or green light, but ML observability is actually going to help you go a level deeper and help with the root cause analysis so you can actually resolve those model failure modes. Okay, again, sign up for your free account. Links should be dropped. You can also just go to the Arise website to sign up for your free account. And as I mentioned, there is a form. If you fill out, you can win swag prizes in that challenge. And depending on how you like to do challenges, we're going to be going through the workshop together. But if you prefer kind of solving it on your own, or if you have experience with Arise before, you can go through that at your own time. There's gifts in there that help you really just follow the process. And when you sign up for a free account, it's not just for the workshop today. You'll be able to use it as long as you like afterwards. Again, free account, you could put your own data into the platform. I think it's up to a certain amount of inferences. So you can put that in. You can actually set up your own monitors for data quality, drift, and performance and test it out for yourself. So the challenge we're going to be walking through today is the credit card churn prediction model. So if you created your accounts, you might see that in your demo models right now. Otherwise, just take your time, create your account. The scenario for the meetup is going to be you're a machine learning engineer, you work at a credit card company, and you're responsible for building a model to predict your customer churn. And not only are you responsible for building this, but you also need to monitor it and monitor it in production for performance issues, for drift, for data quality issues. So you're kind of a one-person team. You're having to see how your model's performing and if you need to make any adjustments to that model. All right, we're going to go into the Arise platform now. Just going to go in here. Alexei, are there any questions so far?
I don't see any. Well, I shared the link to get in for sign up. It's in both live chat and the description. It's called Arise free account. So just click on that. And it's very easy to sign up with Google. So you just accept the terms and then click sign up with Google, and then you have an account.
All right, perfect. All right, so we can go ahead and get started. When you first log into your Rise account, you might see it in the quick start guide page. This is great for you to walk through on your own time. You can explore some computer vision models, some NLP models, click-through rates, and then also try out different workflows. We'll try to get to the bias tracing, but if we don't, there is a bias tracing workflow that you can walk through. You'll just go to the home screen, and here you're going to see a host of example models. So you can play around with these. Nothing's going to get messed up. This is your own account. And again, you can upload your own models as well and start monitoring them. When you first log into the Rise platform, this is the home screen where you have all the models live, the prediction volume and the model versions live, as well as the host of models, the type of model it is. So is it a classification model? Is it a regression model? Is it an NLP model? The performance, so these are monitors that once you set up, you'll be getting red and green lights for performance, drift, and data quality, and as well as the volume. There's also dashboards, so you can create dashboards, and these are very similar to Grafana. If you have experience with Grafana, they're shareable. You can invite people to edit them as well. You can export them, so a lot of flexibility there. All right, so we're going to go into our use case now, which is, again, the credit card churn. So I'm going to click into this model. And then we're going to have the Arise credit card churn model. We see the overview. So we see an overview of performance over time. We can already tell there's something kind of going on here where our performance does dip. And I will say we're going to start with performance, but then we'll get into drift. A question sometimes I ask folks is, when would you need drift as a key measurement for your models in production? And essentially, it's when you can't use performance. So if you have an insurance model, for example, you're not going to get those ground truths back. If you're making a prediction, it could be very delayed, and you might never get those ground truths back. So in the cases where you don't have these actuals, you're going to need drift as a proxy to performance. But we'll start with performance now. For this example model, we do have our actuals back. And then we get an overview of the model schema. Yeah.
Wondering. So for me, it looks slightly different. So I don't have this white line or like this only bars. Like I didn't do anything. I just clicked on Arise demo credit card churn. So I'm wondering if I need to do anything else.
Oh, you can jump to latest data.
Yeah, I still only have bars. I don't know how common this issue is.
Yeah, do other people only have, so you don't have the...
Yeah, I don't have this line, just the bars.
And you're in the credit card churn?
Yeah. So instead of accuracy, I have actuals, average, and then it's nothing.
Yeah. Let me know if other people have any issues. Maybe it's just because you have several things up. Maybe it's taking a minute to load. I haven't really seen that before, but we'll keep going, and then let me know if that gets resolved.
Yeah. Please also write in live chat if you are able to see or if you cannot see the line, let us know.
Yeah. Sometimes it's jumping to the latest data, but I think it's all, this is December 4th. So it's all up to date here. But yeah, if no one else is seeing this kind of screen I'm seeing, just let me know. And then we have an overview of your model schema. So this is going to give you your predictions, your actuals. So we talked about actuals or ground truths, your data type. And then we have a PSI. So this is your population stability index. We haven't computed it yet because this is what we use to measure drift. We're going to set up our monitors next. Information on percent empties, on cardinalities, min and max values, and then categorical and numeric features, as well as embeddings. So currently we don't have any embeddings here, but we do support embeddings and embedding drift. If you're more interested in that, or if a majority of your models are either like unstructured or do have embeddings as a feature, let me know, and we can talk about that later if we don't get into it today. All right, so we're going to set up our monitors. First thing is setting up your baseline. So we have a baseline set, but we can reconfigure this if we like. For our model baseline, we're looking at the production data. So we can also reconfigure this. So your baseline is normally corresponding to your training. A lot of teams are going to make their baseline their training data so they can compare what data is currently coming in, so their inferences in production versus what they actually train their model on. So here, if we're looking at something pre-production, that would be, say, a training version, or we can use a window on production. A lot of teams tend to retrain on a given window in production. So that can be our baseline example. You can use a fixed time range. You can use a moving time range. You could also have it delayed, so it can correspond to your retraining cycle there. All right. I'm just going to keep this production baseline. I'm going to go back to overview, and I'm going to set up my monitors now. So you can choose any performance metric that you'd like. We also have user-defined metrics coming out, so you can enter in a custom metric if you'd rather track that way. I'm just going to keep it accuracy for the sake of the demo here. I'm going to turn on those monitors, and then I'm going to set my drift monitors, my data quality monitors, And then I can send notifications. So if I wanted Alexi to have a lot of notifications flood his mailbox, I can put his email right in here and I can finish it up. And as you can see, these are already set. So it's very fast. And I would say when we work with teams in the industry, they tend to want one of two workflows. They either want it completely automatic, and we do have smart monitoring, and we can set it on very wide models. So ones with thousands of features, and then these monitors get created for every single feature. And they want to just set it, not have to worry about it, not touch it, and just have it working in the background. And then we have teams that really want to explore all parts of their model. They want to know like each segment that's underperforming. They want to know how much it's underperforming by, and they really want to dive in, because if you can improve your performance by 1%, it's obviously very large in terms of profitability. So now we have our monitor set. We can also go and see all our monitors as they show up in the monitors tab. We can also view all monitors from all our models, or look at it at an individual level. So like if you're just concerned with one model, you can look at that. This is really great for teams, very large ML teams that are working with a ton of models. Here you might have seen that I have an organization, I have a space, and then I have a type of model. So some teams will organize by a dev environment, a production environment, a few different environments, and then give access to different teams. So everyone has access to the models they're working on, and it's very collaborative as well.
And I guess here models for the same projects, right? So we can have multiple projects for this credit card churn, and then this is what we see, right?
Mm-hmm. We also have, if you have, say, a group of projects, we do have a projects tab, which we have one of our customers who have about 5,000 models in production really benefit from having a projects tab there.
And then we have a question from Paul.
Yes.
The question is, how is the model communicating with the Arise platform? I guess this is something you will cover later, right?
That's a great question. And some folks probably have questions on kind of the integration side of it. We do have our docs, which are just docs.arise.com. And in our docs, we talk about all our integrations, the methods of which, data is, wherever your data lives, is communicating with Arise. I think the answer to your question is the way we have it set up is there's really two major ways that folks get their data into the platform. So first, you don't have to upload the full model into the Arise platform. There's also in the quick start guide ways to go through exactly how to get your data in. Just note that in case you are looking to get your own data in, but we use either an SDK, so Java, Python. The way it would look is you have kind of a data frame that's production, you name the model, you name the model version, which is really important because we do model version control. And then you select the features. You can input chat values for explainability, metadata, embeddings, and you can send that in through an SDK. We also have API integrations. We have GraphQL, and we have obviously cloud storage integration. So if you want just to import those files, you could set up a file imports. And just in extra detail, we do have customers that are SaaS, and we do have customers that are on-prem. So that should answer a lot of questions people might have in mind of, would this work for my own data? We're also SOC 2 compliant, HIPAA compliant. So depending on the kind of requirements of your data, we tend to be able to meet those very well. If there's any other questions on that, please put them in the chat. And if you can't find what you're looking for in docs, just keep asking the questions. I'm sure other people have the same questions in mind. All right, perfect. So we're now looking at the managed monitors. So we have the managed monitors, but you can create your own custom monitors. We'll actually go in and start editing at least one of these to show you how to do it. But a metric that we set automatically is our PSI, or Population Stability Index. It's similar to KL Divergence, but it has a symmetric property. By that, I mean, regardless of distribution A or distribution B being entered into the equation, you get the same results. So KL Divergence is non-symmetric. So it does matter which distribution you're entering in first. Since we're measuring drift, we're looking at the difference between one distribution to another distribution, and that's going to be whatever production window you're using compared to that baseline that you set. All right, so let's start editing we can either edit a monitor, create a new monitor from scratch, show you exactly like how this would look. Let's create a performance monitor, for example. So here we would name the monitor. We would select the model that the monitor would be in. We would select the performance metric we would want to use for it. We can also have some advanced configurations like the evaluation window, the delays, the versions. And I'm just going to mention on the version control, this is a big win for a lot of teams. Like we do version control for code. We want to make sure all our versions are intact. But in production, sometimes it can be difficult if you want to compare how version, one of your models doing to version 12 of your model, because it's different features you're using and it's different metadata. And so if you want to really compare different models, this is how you can do so. And you can also set your monitors per version. The way we actually charge, so this account is free. It's the free platform. It's up to a certain amount of inferences. I think it's like 500,000 inferences. But you can check that on our page. Once it gets to the enterprise level, it's still charged based on inferences. So you can have as many monitors as you like. We don't withhold parts of the platform, so you still get all the features. Just it's as inferences go up. That's how we price our pricing model. And then when we look at alerting, we have the auto thresholding where you can trigger your alerts, and you can toggle this off if you don't want auto thresholding. You want to be very particular. We want to make it as simple as you would like, but also make it as configurable as you may need. So having those different options is really great for most of our teams. Any questions on monitors before we get into performance?
No, not yet.
Okay, perfect.
Do I need to run any other poll? I kind of enjoy doing this.
Yeah, you want to run more polls? Maybe because a lot of teams are now caring about responsible AI, fairness, bias checks. Is bias a concern for your models in production? And even if you don't have models in production, because I know it's a 50-50 right now, you can think about like, is bias, very prevalent and like should be something people need to be concerned about for these models in production. Like right now we're seeing the trends of like the AI generated art and everything that's going on there. And I know there's big discussions going on right now of giving credit to the artists and giving monetary compensation to the artists. And I think it's only getting bigger, and we're just seeing more and more use cases of teams either trying to prevent bias at the beginning, or they've already run into an issue, and so they're trying to prevent further issues of bias and fairness. And we can
maybe like I imagine that there could be somebody who might not know exactly what bias is. I guess here the example we use is credit card churn example, right? So what kind of biases we might have in this? I know I'm like, you will probably cover that at the end, but maybe you can quickly answer that to give an example.
And I'm also happy to jump around as well, because I normally, like in person, I normally base what I show next, depending on the questions, depending on what people are most interested in. And so we can start with this. And I think it's a very important point too, because teams will come to us and say, I want explainability. And when they say that, explainability is great. Most of the time, explainability comes from SHAP values, and you either have local explainability, like figuring out why one person was rejected for a loan, cohort explainability, trying to figure out why everyone, over the age of 80 was rejected for a loan, and then group, which tends to be the most used, like the global explainability, which is the overall, what's impacting my model the most. So this is an example of global explainability. When we look at our credit card churn model, we see marital status is playing a big role in credit card churn. And, we'll get into why that is, because we're going to find it in the data together. But then it just kind of goes down into what's the most responsible for making the decision. The thing with explainability, though, is it doesn't tell you about whether or not these decisions are correct, whether or not these decisions are having a performance impact, whether they're bringing down, user satisfaction, whether they're bringing down your KPIs. And that's really key, because it's nice to know, the most important features. You can use that as a method to kind of triage your features in terms of, oh, maybe I should check the data around this and this and this because it's a very important feature. But it's not going to tell you, is something actually biased? For that, you need individual bias tracing, which we get into our fairness tab. I won't go into this too much because it looks exactly like our performance tracing, but essentially you are tracing for performance. You are trying to figure out how one group performs against another, and that's how we look at bias. Because if I'm making decisions for group A and decisions for group B, and group B saying like these are poor decisions, if they're poor for group A too, it's just a bad model. It doesn't mean algorithmic bias, but if it's poor for one group and really strong for another group, that's where we get that disparity. And we do that by compare something like I even have some metrics here, like the recall parity, the false positive rate parity, the disparate impact, by comparing group A to group B in terms of performance and seeing if they perform the same. And we will get into that. We can actually probably get into that after our performance tracing. Any other questions in the chat?
Yes, there is a question from Eduardo. Is it possible to deploy this application in a private cloud? And the comment is so Eduardo probably has some data privacy concerns.
Yes. So we do have on-prem customers that obviously that's in their own cloud. We have different variations on it too. There's ones where we help with the install, and we have access in terms of maintenance. So someone can still go in, update, maintain, but it is on their private server. For the free version is the SaaS version. But we are working to get a few like additional options to folks. But if you are looking to just do this on your own, I would just take a file. And again, even the free version, like HIPAA compliant, SOC 2 compliant. So there really shouldn't be too many concerns. But if you still have those concerns, you can kind of take your data, create a mock data set, and then or kind of obscure the feature names and kind of just put that in, because then you can still see where in the data the issue is happening. But you don't have to worry about like if your account gets hacked, because no one's going to be able to make sense of it but you. So we do the installs for enterprise teams, but for if it's just you, like those are some options.
By the way, so I finished the poll, and 100% of people who answered said, is bias a concern for your models in production? But I'm a bit concerned about the bias here in the responses.
The bias of the bias poll?
Yeah. Because I think probably for those who replied yes, for them indeed it's a concern, but those who didn't reply, they just didn't know that they have this concern yet, so they weren't sure probably whether to reply or not. So
yes,
that's
a good skew though to have, because everyone who did reply like knows they should be concerned. So it's definitely like this. I like this group. This is a strong group we got here. So yes, thank you. It is a concern, and I think it's only becoming more and more of a concern as we use and leverage more and more data every day. Perfect. So when we think about performance, we want to think about kind of breaking down the data. A lot of teams, when they know there's an error, they'll do SQL query after SQL query, or they'll go into like, Jupyter notebooks and just keep going in through pandas and try to figure out where is it, where's the error. And so for the Arise platform, we want to be able to show you the full range of time, and then being able to look at a performance breakdown. So here we can see our accuracy over time. This is overlaid with traffic or volume, like this is your volume of inferences. So sometimes, traffic is stable, and then like maybe during the holidays, you get surge in volume, which often leads to your models drifting or underperforming because of the kind of variety of that data set. It's probably not the same as the distributions you trained on. So looking at seasonality changes and all this can really help kind of break it down. So we want to look at the worst performing slices of data. And again, we look at this from a volume perspective. Feature importances are really important, I guess you can say, and we can look at that by triaging our features. So we're looking at the worst performing features, but also the ones with the greatest feature importance. So that's nice to have. But when we look at the worst performing slices, the reason volume matters is because if you spend your time focused on fixing a feature that maybe is important, but is very low percentage of that data, you can only increase performance so much. So keeping that in mind, normally there's a correlation between the most important features and the ones getting the most volume, but that's not always an exact match. So here we're seeing things like utilization brings down performance a lot. We see things like marital status, specifically divorce and marital status is bringing down performance a lot. And then we can actually go into that is we see our features, we have tags are metadata in the Rise platform. And then we have these histograms. So whatever performance metric you use, we will have a gradient on worst to best performance. So for accuracy, 0 is the worst, 1 is the best. We want to get it to as close to 1 as possible. And then you can see from the heat map where that lies. So we know marital status is having a big impact. We also saw in our SHAP values, it has a very strong feature importance, which we see here. If I go into marital status, I can see that a majority of the folks are either like about 40% are single, 45% are married, some are unknown. But then we have a really strong like darker area, underperforming area. So this is an input to our feature marital status. We see divorce is really pulling down our performance. And you could put in the chat why you think this might be the case, but we see it's taking down our performance by a decent amount. So if we're able to, somehow fix this, it would bring up our performance a lot. Right. So, and if you didn't kind of connect the dots there, like divorced folks are probably canceling their credit cards. They're probably churning from joint accounts. And the nice thing about, critically thinking and understanding something like this is a Kaggle data set. We didn't change this part. So it's nice to get these insights and maybe, hey, marketing should, send these addresses, promotional offers on opening a new account. And, you get team communication in it, similar for like other churn models where it's like, oh, we see people are churning from this region. Maybe that's where we need to send more ads. Maybe that's where we need to kind of target sales. And you can export all these into dashboards, surface those insights, and you can also export segments of data if you want to, run it yourself in your own notebook. But what's really nice is that we can also add this cohort as a filter. So right now we're working at an accuracy of about 70%. If we add this cohort as a filter, hold on. Oh, wait, my bad. I filtered out of it. So yeah, so what we can do is we can add this as a filter. So we could add it as a filter or we could exclude it. So if I exclude this poor performing segment, I see that my accuracy jumped up about 3 to 4%. And that's because, when we're kind of adding a blinder to the data, we can see how much we could perform if we get that status, if we get the data around that to perform better. So I can remove these. And even if it's something you can't necessarily change, like understanding your model is really key. And that's where more understanding needs to be around, like knowing what is pulling your model up, what is bringing your model down. And that comes from looking at your performance breakdown. What a lot of teams like to do is these comparisons between different environments and different versions. So we'll have teams that spend a lot of time looking at different production versions, like version 1, version 2, version 3, and do these comparisons. Or you can even have different validation sets, validation to validation, training to training, production to training. You can have all of them set up. And then what we're actually able to do is we can zoom in on where our model's performing well, zoom in on where it's performing poorly, really look at the performance between the two. So we see when our model's performing poorly, it's about, it's 2 times better than what our performance is when we're underperforming. And then we get our performance breakdown where we can actually see the mirrored histogram. So you can compare directly A to B. So we have our A to B comparison here. I know it's like a lot to see and kind of a lot to comprehend. It's because we're taking thousands of queries, thousands of commands, and condensing them into one bird's eye view of like visualizing that data and then being able to see all the correlations with it. So it is a lot, especially if it's your first time seeing the platform, but it's a lot because there's so much you can do, and we're eliminating all those extra commands. This is why it takes teams about 20 to 30 minutes to find where in the data a major error is occurring versus, like I said, at least a week to actually figure out where that error is. Because you can go through each one of your features, compare the histograms, and see how your model is performing. So we saw that marital status, if we go into marital status, being able to see A to B, what our performance is, what's bringing down our performance. And it all comes from first taking your A, taking your B, and doing that comparison. A lot of teams building models will say, do you have a model to model comparison? And we do. You can compare models to models, but what we find teams really need is that version to version, because oftentimes they're just updating different versions of the model. They have a new version where they have an extra feature or they retrain their model, but they don't want to get rid of a model that's performing well. So you can have these different versions in play and be tracking them and comparing them. You can also do the breakdown by metadata. Currently, there's no metadata in this set, but you can add that as well. So if I say I take away, one of the areas, and I'm going down, and I want, I want to see the worst performing areas. I can go by my worst performing slices, and I can look at kind of the utilization. So low utilization. In my mind, if I'm a model builder, I can know that low utilization is bringing down my performance, but now I actually have enough to say how much it's bringing down my performance. And I could add this range as a filter. I could view the explainability and kind of create reports. Because a lot of times we use a few metrics to see how our models are doing in production, but now you can really dive in and see like, what are the worst things? What can I change? How can I ultimately improve my model? And teams that are able to bring up model performance by a few percent, it often equates to millions of dollars and to increase customer satisfaction. So that's really what we are looking for there. All right, any questions before I go into drift? Let me do it quick.
Not yet.
Perfect. Okay. Doing well on time here. Okay. All right. So when we're looking at drift, and I can also reset any of my time frames. So whatever time frame you're looking at, note that you can drag and drop to zoom in. You can drag and drop to zoom in on bins. The bins will adjust. But maybe you have like, I want to look at, last month or last year, or I want to look at, this season compared to last season. You can always change that out as well. All right, so we're looking at the PSI. Again, you can look at KL divergence, you can look at JS distance. We really like PSI for the symmetric property, the scalability aspect, and it works very well for categorical as well as numeric features. We're right now looking at our PSI for this model in production. So we're looking at credit card churn, and we see our PSI and we see it peak. So if our drift is peaking, that means the distributions are diverging from each other, and we have accuracy overlaid. So teams that don't have ground truths, they're not going to have this accuracy. They're not going to be able to say that the drift is bringing down performance. They might just have this, and they'll have data quality. So when we see hardly any drift, so I'm going to go to a data point here. where the distributions match. So we have our blue green, which is our current distribution, and then we have our purple, which is our baseline. Here they pretty much match up almost exactly, and there's no drift. When we're seeing the ultimate drift points, that's when we really see the divergence come into play. So our training distribution and our current distribution are really far from each other. And right now I have the look back period as 3 days. If I go to config, I can reconfigure any of my preset things, and it will propagate through the platform. And then we want to go into our drift breakdown. So let me know if there's any questions on this, but essentially we want to have low drift. And there's going to be some features that are going to drift naturally, which we're fine with, but features that are drifting that shouldn't be, that's where we're really going to try to dive in. So when we see our drift breakdown, we have our drift, which is our PSI score that we calculated. We have our feature importance, which is from our SHAP values, so our explainability values. And then we have our prediction drift impact. And we get this by multiplying the two. So we're saying this is the most important feature that has the most drift. So trying to get both of those key metrics into play. And we're seeing a very high prediction drift score with gender. So if I go into gender, and this is also going to be relevant for those that have said bias is a big concern in the industry, which is everyone. So it's relevant for everyone pretty much. Here we see that when we're in kind of the underperforming area, actually, so I'll click on when we're performing well. So we're performing well, everything is going great. We see pretty equal distributions between male and female. And as we go down and start experiencing drift, we see that there is a new input, which is this non-binary that is in our current or production distribution, and it's not in our baseline. So what this means is that we didn't train our model on a non-binary class because we're only seeing it in production. We're not seeing it in our training. So we need to export this data, use it to retrain our model, because right now we don't know if our model is making good or bad decisions based on having an additional input here. So that's something to consider. And we can see like the cardinality increase from what we expected. A model would also trigger. So our model would trigger here for drift and would trigger for our cardinality change to let you know there's a new input. And we can view this now in our fairness tab. Quick time check. Okay, so we have 10 minutes left. Okay, that's pretty good.
We actually have more. So
okay.
we have like extra half an hour.
Okay,
so
perfect.
You don't need to rush. So usually for workshops, we have 90 minutes.
Okay, great. Yeah, I know.
Of course, if you have some time to, because I do have some questions, but I want to wait till you finish and then ask them.
Okay, perfect. Yeah, so that's good because I know some people can only make the 1 hour, so we'll get through a majority of the platform, and then definitely have a half an hour to chat and get everyone's questions answered. Perfect. So the way we look at bias tracing is similar to how we look at performance tracing, because we are looking at essentially the performance of certain selected groups. So if I select something like disparate impact, and if you're curious on what these metrics mean, how they work, I highly recommend the course, the free ML observability course, because there's an entire unit on fairness and bias. So I can select a feature or a piece of metadata. I can select the attribute. So we're going to select gender here, and I'm going to select male here, and I'm going to select female here. I'm going to select male here. So this is my base and my sensitive group. Oh, I need to configure my positive class. So I'm going to do that. This is just in our config. So if you didn't do that at the beginning, I didn't do that at the beginning. You have to select a positive class for certain metrics. So if I selected a certain performance metric, I would need to configure it here. I'm going to make my positive class churn. I'm going to save that, make sure everything's updated. Perfect. And I'm going to go back to my fairness tab, and then it's computed. So the way that we look at parity scores, it's the 4/5 rule. So anything between 0.8 and 1.25 is supposed to not exhibit algorithmic bias. And this is just a rough, idea. Nothing's been completely figured out on this, but in general, if you're operating between 0.8 and 1.25 between a base and a sensitive group, you're pretty safe on the bias side. So it's unlikely that your model is exhibiting like extreme bias. So like that tends to be the goal for teams. Obviously, you want to get as close to 1 as possible, because if you get to 1, then the performance of one group versus another group is nearly identical. So closer you are to 1, the better. But being in this range is really good. So we're seeing male and female are getting similar performances. So that's great. So we're not seeing anything too different there. So now let's put in male and female versus, and see, our parity score went up as we included an additional one, and we'll make our sensitive group here non-binary. Oh yeah, that's really bad. So it's a pretty poor score. And it's probably taking into account, like we may not even have that data in part of the platform. So if you're getting a crazy score, like it's really high or really low score, you probably didn't train your model on that input. Is probably the first key thing that you see. But those are the main things to kind of look for. Like if your score is pretty crazy, that's a key insight that your model's not performing very well. And you can adjust the dates to times when it's only where the sensitive group data comes into play. Like maybe if I just look at like this area, for example, you can look at that. So performance actually isn't too bad at that time, but I would still retrain your model on this new data, because it doesn't mean that performance is going to be at that level. Like this is like a day or two, doesn't mean it's going to be like that all the time. In fact, anytime there's new data being introduced, that's normally when we see models start decaying gradually over time and like slow data drift. And that's often why it's so hard to actually troubleshoot these models in production, because the changes are very subtle and it happens gradually over time. So you could be losing a few customers like every week, and then all of a sudden you're losing 10 customers every week, and then you're losing like 50 customers every week. So it's being able to figure out these things early. Like being early is going to be the most important for making sure that your models are performing as you would like in production. Okay, so that covered performance tracing, drift, and fairness. For those that have to leave now, I want to thank everyone for coming. We are going to have some extra time for questions and to go into some different aspects of the platform.
Yeah, thank you. Just wondering, you have more than 5 minutes, right? You have some time after. Okay.
Yes.
Because I don't want to keep you here, keep you hostage. So I was really wondering. So you showed us this demo credit card churn project, which was already on the platform. But how do I go about putting my own data there? I think you briefly showed it that there is an option to upload, but I'm wondering if it's not too difficult. You can walk us through this process. Like, how do I do this?
Yes, absolutely. So I just clicked on the quick start guides. So this is the first page you see when you enter the platform, and then you get to everything from the home button. But if I see something like like model monitoring, and I want to do the model monitoring first. If I want to create dashboards, I can create those, and we'll walk you through it. And here's the send in your own data. It's also more like these are example Colab notebooks for getting your data in. This is actually how we get those example models in. So if you have a churn model, it might be easiest to just clone the notebook and copy that over. Our Slack, and more on our documentation. Most is in the documentation, but if you can't find it, asking on Slack, and those are just general best practices. So if I click send in data, here is, you can even resend in a demo model. So if you wanted to send in one of the notebooks as a first step, you can do that. kind of helps you just understand the process. So here you have like your various keys, you have your capture, your inspect, and then you can like send these in individually. This is just a toy account that I created now. So I mean,
I was wondering what can happen, like if somebody takes these keys, the API key, what can they do with this? Like, can they remove data or only submit data?
you can only so for this, yeah, like you can send it in. I also have my keys here, but yeah, I mean, if you want to send data into my platform, go ahead. It will only let you do so much,
So it
but
will not allow any destructive actions.
yeah.
Will it?
I'll
Okay.
check your models for bias, just send them here. And yeah, so the key ways, so we mostly have it so you have to do 2 checks to actually delete the data, because we make it easier to send in the data than we do to delete the data and delete the models, because we don't want anyone accidentally deleting them. I can actually show you how to delete your models in a sec. And then there's also like the cloud storage option. You can visit like the file imports page. So the way we got to here is I can kind of just like go through to the side of everything we see. So this is our home button. This is if we want to see all the models we have in production and the monitors. This is for our dashboards. This is for like each monitor. So we have our models and our monitors tabs respectively. And then we have our projects tabs. And this is where we are right now. This is our file imports. And if you are using the Python SDK, you want to copy over your space keys, this is where you do so. You can also manage your account here. If you want to add certain members, you can add the members here and kind of just have an overview of the space. All right, perfect. And then you can set up like a new import job, and then you can use Azure, Google Cloud Storage, an S3 bucket, and each one of these will show you the steps of how to do it.
I guess here the idea is if I already have a process that is writing data to S3, saving logs, saving predictions there, what I can do with Arise right now is just point to this bucket, to the prefix, and say, okay, here every day I dump new logs from my model, right? And then it will just automatically discover new files and ingest them and display them, right?
Yes.
That's cool.
Yes. Yeah. So, and yeah, so just depending on your workflow, we have teams that only use like the Python SDK. We have teams that use Azure, teams that use S3. So if there's anything that seems like difficult or you have a certain setup, just message us through the Arise platform support channel on the community Slack group, and we'll get it all figured out for you.
And I noticed that when you showed how to use API that there were like 4 tabs. The first one was real-time ingestion, and then the second one was batch. And I'm wondering how much extra overhead does it add when I do real-time? Like how fast it is?
So and I guess I could say like one of the main things Arise wins deals on is our scale. So we take in, we take in data from some of the largest platforms, like the apps you have on your phone, from ad tech teams. So it's a ton of data, and it's very fast. So anything that's in the free account will be very fast. There won't be any issues if you're doing real time and you're using a free account. It's when we get to crazy massive amounts of data that we have to make sure like everything's getting through. But yeah, if you're just in a free account, Python batch, you can send it in either way.
Mm-hmm. Okay. Yeah, and then there is a question from Marcos. Is this all real-time monitoring, or are there also specific features for batch monitoring? I think I see that here we have a tab Python batch, right? Maybe you can tell us a bit more what kind of features are there, and if you have any batch monitoring specific features.
That's interesting. Yeah. So you could send in your data however you'd want. And then once you set up those initial monitors, they're monitored in real time as the data comes in. So as soon as that data's in, it's being monitored. And you'll get alerts automatically as it's, as that data is coming in. So that's a key thing. So once you set up like a batch process and like that data is coming in consistently, or that real-time data is coming in, it's being monitored as soon as it hits the platform based on the monitors you had set up, as long as you only have to set them up once, and then you can continue to edit, change them, and add to them. That might help to even go back and see a bit more of these monitors. And one thing I didn't get to today, but I will be having an additional workshop on later on. So if you sign up for the Arise community Slack, you'll be seeing emails from me. We'll go through a whole NLP use case and how to monitor drift embeddings, because we monitor your embeddings through a latent space, which is really neat. So if we go in our fraud use case, so in your example account, your fraud monitors are already set for you. So here's your managed monitors. I think we went into editing. I think we went into a performance monitor. So let's go into a drift monitor, for example. So here, also, if you want to edit any of these monitors, you can edit it and then you can duplicate it so you don't accidentally delete any specific monitors. And so I can duplicate it just to make sure that everything is good. So again, you have the monitor name, you have the model, you have the feature, and then you have the dimension. So the dimension is, metadata, the feature here, the metric you want to monitor against, the advanced configuration. So maybe, you have an evaluation time window you have a delay evaluation, and then these versions. So you can select, all your versions, you can select one or two of the versions. So we automatically set your monitors for every feature, but then you can create more for particular versions, particular metadata, and group by it as well. So if you have a feature like location, and you want to set additional monitors on a few of those inputs to locations, you can do that as well. So say you have like feature, and then you want to continue to add those filters. Every part of the platform, you're allowed to add filters because it allows you to dig deeper and do several layers down of what you're first seeing with your data. So just know, like, those are the levels of monitors that you can have in place. And then again, auto thresholding, you can have it custom. You can have notes for your monitors. And then we do integrate with like Ops, Genie, PagerDuty, Slack. So if you have one model that you really care about, you can have those sent directly to you.
Do you want to run any more polls?
So we did. Okay,
How
so
many? If you have models in production, or if you have put models in production, then if you know what ML observability is, and then if you deploy models to production, if is bias a concern for your models. So we did 3.
So those are a lot of the main questions I asked. I guess since we're towards the end now, maybe a question on do you see ML observability like being useful for your team? Or because a lot of times I just like to see what people take away from this. Feel free to message me on the community Slack of the things you wish you got to learn about, or put that in the chat, because we still have some time if there's more questions. I know we went through.
Oh yeah, we have actually questions.
Okay.
So that's why I first wanted to run the poll, start the poll, collect the answers, and then in the meantime, I wanted to ask you the next question from poll.
It's good triaging. Yeah, excellent.
What does actually triaging mean? You said this word like 3 times, and I was like too shy to ask you what it means.
Absolutely. So the way that I think about it is, if we use something like feature importance, it's great to have it as a tool, but I like to use it to like kind of triage the where I should spend my time. So
it's like locate or like pinpoint. What's the synonym for triage?
I think it's like almost like divide up responsibilities. I'll look at the actual definition. we like to be like on point here. Okay, yeah, the assignment of degrees of urgency. Yeah, so a lot of times, like when you go to the emergency room, there's like a triaging system of like this person needs to go to the emergency room, this person on the floor.
Like
So it's a way to,
diagnostics or
yeah, assign urgency, I think is
assign
the,
urgency. Okay,
yeah.
what does it mean? Like prioritize, sort of to understand
Yeah,
like how important.
prioritize, yeah,
Ah,
assign,
I see, I
yeah.
see.
So when you like triage, it's like, if I only have an hour to explore, my model in production, like I only have an hour in a day to see how it's doing. I want to see the worst performing features first because those are the most urgent ones. If I want to look at drift, I'm not going to go down to these features, which aren't hardly drifting at all. I'm going to go to the red lights. I want to prioritize the red lights, the things that are stopping me from advancing my skills, things that are stopping my model from performing optimally, things that are stopping, sales from, making deals, anything that's, your model is supposed to be doing and not, that's what I want to prioritize. Because that's why here, when I triage, I see these are the most important, worst performing things are at the top. And that's what we do for performance. That's what we do for drift. So you can see that this is where your time should be spent here, an education level where, I'm seeing I didn't train my model on a certain input. Oh, I went to education level. Oh, this feature is also drifting. And we're seeing a lot of drift here between our current distribution and baseline. So, it's not always that we didn't train something. It's that sometimes our input distribution is very off. So yeah, just quick note there. And we triage with performance. So these are the worst performing features that are the most important features that we have. So this is where I want to spend my time. It's good to spend time down here, but it's not going to help your model as much as spending time up here.
So the poll is complete. And as you probably can guess, 100% said that observability is important and useful for their teams. But I might suspect that there is again some selection bias because we asked that question on a workshop about observability.
It's totally balanced, complete class balance. Like,
okay. So then there is a question from Paul. Do you know any toy datasets on which we can build personal projects to learn more about monitoring?
Yes. So like I said, this data set's actually a Kaggle data set that we put in. But what's really nice, and I think the first thing people should start with is kind of recreating what I went through. You can do that in the challenge. This kind of walks through each thing that we did, and you can put in your own answers. And if you submit it, you can win swag. So that's the first thing I would recommend. And then I would recommend going through the example models that we have on here because you can experiment, play around with them, discover insights without having to worry about the things that might have gone wrong in that data set you're putting in. Like these have already been kind of vetted. There's no weird things going on with it. Because a lot of teams, as soon as they put their data in, they realize a lot's going wrong with their data and there's a lot of things to fix. And so they're working on that to get to a point where it's easy to monitor. So it's a whole process. But yeah, besides these, I would say Kaggle data sets, if you find a really interesting data set online, you can put that in. And there's a lot of tutorials for it.
I think there is some deadline for the challenge, right?
Yes. So the challenge is due at midnight Pacific, but I'll probably look at it. If you get it in before, let's see, if you get it in, before the end of the week, honestly, like, and you go through and you take the time to do this, well, swag will still be considered. So it says at midnight of midnight PT, Pacific.
A bit tight, I think.
Yeah, which I mean, it's realizing, a lot of people, it's nighttime there. Yeah, as long as it's done by midnight on Friday, Pacific time, you'll still be eligible for
Maybe
swag.
Hawaii time?
Hawaiian time? Sure, I probably won't be up to grade it and like to send out swag, but yeah.
Okay.
Thursday midnight Hawaiian time. Just have it in. But yeah, but if it's by like the end of the week Pacific time, yeah, you'll be eligible for prizes.
Okay, thank you. I don't see any more questions. Oh, actually, no, I am wrong. There is a question from Eduardo. So I work primarily on computer vision, so I'm not sure this specific tool can help me. You probably can say that it's not a correct conclusion, right? Because you can monitor embeddings, right? Well, but
Yeah,
I will let you answer that.
yes, I was waiting for someone to say, like, I do have unstructured use cases. So thanks, Eduardo. I keep accidentally zooming in. So we do have embedding drift for unstructured use cases, things like, computer vision and NLP. So if your model is like making a decision, we do embedding drift. So we can actually look at, if you see here, our point cloud, you're able to look at your clusters, kind of color code by correctness, look at clusters. And we see the main thing here for us is to see when there's a new cluster that has drifted. So we do the dimensionality reduction technique. We have UMAP is our kind of base display. So the way we have it here, right now we're looking at like correct and incorrect based on the decision of the computer vision model. I think I forget exactly what it's making the decision on, but essentially we want to be able to monitor our clusters in production and see is when we do the dimensionality reduction technique, is our Euclidean distance changing? Is our cosine distance changing? Like because if it's increasing massively over time, you probably have a new cluster. And a lot of times that means data that your model is either making poor decisions on or your model's not trained on.
Yeah, I think from what I see, it's making predictions about the action. So here on this picture, so the prediction was using laptop, but the actual label was calling.
Oh, okay, yeah.
Yeah, so probably an action. So that what you do is
The
you can
labeling.
you can put embeddings to Arise, and then it will build this nice visualization. Then you will be able to see clusters, and then it will also, like when you select a cluster, it will show you what are the pictures in that cluster, right?
Yeah. So if I just lassoed these points here, so I'm looking at, this cluster in particular, we see a lot of correct examples here, eating, sitting. So it is labeling, that's the task for it, this part. So we're labeling, we're getting a lot of things correct. I'm curious, like what's actually over here where there's a lot of things that are incorrect. Yeah, texting, sitting. Yeah, that's a hard one to label. So I think it's depending on. So this is a very distinct cluster on food. It's well trained on food. It's doing well on food. This is a little bit more of a mashup. But yeah, so that's how we're able to do it and set your monitors on embedding drift.
What is this data set? Do you remember? Because this example is very nice. Gotta know, like I don't think humans can actually label this correctly.
Yes, it's definitely in our documentation for like our examples. Actually, there was that computer vision use case when we were looking at getting your data in. Let's see here if I can find the exact. Oh, okay. So here we have like a lot of our examples. Here's embeddings in NLP. So if you go to the collab, you'll be able to find it. Most of them are Kaggle or a lot of the big open source data sets.
Yeah, thank you.
And we have a reviews data set for the NLP. So figuring out with the drift on those interviews. And there is we did put something special in there that you'd be able to see the embedding drift and figure out what is bringing down your what's bringing down performance, what's actually causing that drift. So if you go in the NLP example, you'll be able to see that.
Did you have an NLP example here? Like I imagine it would look like very similar to this one, but except for images, you will see snippets of text, right?
Yeah,
Or not quite.
this is the regular one we use. So we have a sentiment analysis classification one where we're looking at reviews. Also, depending on your laptop, your settings, like we're doing the UMAP rendering. It's computationally dense. So just depending on your setup, it may take it may be really fast or it may be slower. But that's kind of depending on your laptop there. So yeah, here we have different reviews. We have positive, negative, and neutral reviews. So here everything's looking good. We're at a low point. If I go to a point here where now we're looking at peak distance, I can generate the UMAP visualization. So that might take a second. I've been loading a lot of these, but here we go. So this is where our distance peaks. So whether it's a cosine distance or a Euclidean distance, we're seeing that distance increase. And now we're seeing an additional cluster that we didn't see before. So just to label these points so you can see them. So here we have positive reviews labeled positive. Here we have negative reviews that are negative, that are named negative. And then I'm guessing this is going to be neutral because we have pretty much 3 distinct clusters. And yeah, so these are neutral reviews, but we see here that there's a cluster that is performing really poorly and it's new, right? It took up our distance. So this is a new cluster and it's performing poorly. And so here we're seeing something like doesn't taste the best, blah, 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 like kind of a neutral review. If I select these points, I'm now seeing, and they're color coded here as well.
It's not English.
Yeah.
That's why it's separate.
Exactly. You got it. Yeah. So if different reviews, and interesting enough, some of because we added the Spanish reviews, but there were already some in this cluster that were using like a different language or a lot of slang terms that the model couldn't understand. So it generated its own cluster. And you could color by correctness or by data set or by feature. You could have confusion matrix and kind of select on that as well. So you can select maybe only false positives and kind of see how this is doing. Oh, that's interesting. A lot of true positives here and a lot of true negatives. So yeah, really helps you dive in. And it's also the most sophisticated embedding and unstructured capabilities that we're using with our platform. I was just hanging out with Leland last week, who helps work on the platform. He founded UMAP, and it helps kind of go back and forth with us on our NLP research and the decisions we're making there. So a lot of times when you see what can be done to monitor my unstructured models in production, most are using some kind of histogram, and they're taking a layer and they're doing a histogram and they're seeing if that histogram is moving, which is, I mean, that's I would say level 1. This is the more advanced version of kind of the correct way. Like you should be looking at it in a few dimensions and reducing those and understanding your data on a deeper, more sophisticated level if it's unstructured. We're also having the ability to lasso these, export them, and you can label them as Spanish reviews. So where you can export it easily to retrain your model.
Pretty interesting. So if I understand correctly, what we should do next after this workshop is first go through the challenge, right? If we want to get some swag or learn more about RISE or both, right? So that's the first thing.
The swag's the big incentive there.
So, and then after that, you have a course, right? So if you want to learn more about that, then there is a course on ML observability, and this is something we can take after the challenge, right?
Right. Yes. That, and then joining the community Slack, because if there's any trouble along the way, we can get your questions answered, whether it's on this talk, if it's your own model you're trying to get in production. We also do some giveaways, and it's it's the largest ML observability Slack group. And like I said, we talk about more than just monitoring and production. We talk about like sophisticated models and think about, you know, how these are working in production and how to best like serve the needs of our customers and our community.
And I think you host events quite regularly, right? So
Yes.
if we sign up to the community, we will get updates about all these events.
Yes. Yes.
Cool. Okay, well, I don't see any more questions. And I don't have any more questions too, which means I guess we can conclude this. You want to say anything before we finish?
Well, just thanks everyone for taking time out of your day to learn about ML observability and best practices. Again, please reach out to me on Slack. I also included my LinkedIn in the message that was posted. So that link is there as well. I'd love to connect and learn more about the models you're building.
Yeah, all these links are in the description or live chat. So depending on when you watch it, if it's now, then go to live chat. If it's in recording, then all the links are in the description. Okay, then I guess that's it for today. Thanks a lot, Amber. Thanks everyone for joining us today too. And yeah, I'll see you soon, I guess.
Awesome. Thanks everyone.
Goodbye. Have a great day.